Hi everyone, in today's video we are going to be looking at factorization of quadratic expressions. The objective of today's lesson is to help you learn how to factorize quadratic expressions via the cross method. Let us first do a recap on what factorization is. Previously, when we were in Sec 1, we learned about expansion and factorization. Factorization is seen as the reverse of expansion, where it is actually the process of expressing an algebraic expression as the product of two or more factors. So one example of expressing expression as a product of two or more factors would actually be this, whereby A is one factor and then B plus C comes together to form another factor. Okay, so in this diagram over here, we see the expansion from A times B plus C over to AB plus AC, where we apply the distributive law, and then from AB plus AC over to A times B plus C, that is called factorization, where we apply the method of extracting common factors. Let us then recall what is factorizing by extracting common factors. There are actually many methods of factorization for which we will learn new ones this year. Okay, in this particular video, we will be covering one more new method of factorization. Okay, but before that, let us first recall what we learned in Sec 1, where we learned how to factorize expressions such as 12x plus 8, negative 15x minus 6, negative 10ax plus 25ay, and 6x squared plus 15x. So I hope that these expressions over here look familiar to you, and it rings a bell on how to go about extraction. It rings a bell in terms of how to go about doing factorization by extracting common factors. Let us first take a look at this example 1. We have 12x plus 8. First, you must be able to recognize what are the terms in this expression here. We have two terms, one of which is 12x and the other one is plus 8. So between these two terms, 12x and 8, we need to identify what is a common factor. We first look at the numbers 12 and 8 and notice that the common factor between 12 and 8 is 4. However, in the first term 12x, we have an x, and then in the second term, we do not have an x. So there is no common variable, there is no common factor, there is a variable. Okay, so after identifying that between 12x and 8, there is a common factor of 4, we will take that out, and that is what it means by extraction of a common factor. However, we must remember that it needs to be equivalent, so it cannot just be equals to 4, it needs to multiply with something. Okay, so what is it that it will be multiplying with? This remaining factor will actually consist of your 12x after dividing by 4, as well as 8 after dividing by 4. Okay, so 12x divided by 4 will give us 3x, and then 8 divided by 4 will give us 2. Or rather, more specifically, it's a positive 2. So therefore, my factorization of 12x plus 8 will be equals to 4 times 3x plus 2. Let's now take a look at another example. We have negative 15x minus 6. So again, we identify what are the terms in this negative 15x minus 6, and that will be negative 15x as well as negative 6. Between these two terms, we identify the common factor. We observe that there is a negative sign in both terms, so negative 1 is actually a common factor. But between 15 and 6, we also notice that there is a common factor of 3. So therefore, the common factor between negative 15x and negative 6 will be negative 3. There is no common factor that is a variable. So taking that out, we need to consider what is left behind for our remaining factor, and the remaining factor is after negative 15x divides by negative 6 and negative 6 divided by negative 3. So negative 15x dividing by negative 3 will give us a positive 5x, followed by negative 6 dividing by negative 3 will give us a positive 2. And therefore, the factorized form of negative 15x minus 6 will be negative 3 times 5x plus 2, where the multiplication sign is being replaced by the brackets. Let's take a look at another example. We have in this case negative 10ax plus 25ay. In this example, there are actually two ways to go about factorizing it. There's no right or no wrong in either one of the answer. Okay, both answers are acceptable. Right, let me explain to you the first option. Again, we first identify what are the two terms. We have negative 10ax as well as 25ay. Between negative 10ax and positive 25ay, we observe that there is a common factor of 5 between the two numbers 10 and 25. And then amongst the variables ax and ay, there is a common factor of a. So we will extract out the common factor of 5a. Then we need to consider what is left behind inside the brackets, and that will be taking negative 10ax divided by 5a. That will give us a negative 2x, followed by positive 25ay dividing by 5a. That will give us a positive 5y. And therefore, one of the answers for factorizing this negative 10ax plus 25ay will be equals to 5a times negative 2x plus 5y. Let's take a look at the second option. So for the same expression, again we observe the the two terms, okay, negative 10ax and 25ay. We see that in both terms, actually we can consider extracting out negative 5a. So earlier on, we extracted out a positive 5a. Okay, this time around we extracted out negative 5a. You can consider that, just that it will change what is left behind inside the brackets. So by the same method, negative 10ax dividing by negative 5a will give you a positive 2x. And then positive 25ay dividing by negative 5a will give us a negative 5y. So let's observe that, okay, in this second option, we have the answer to be negative 5a times 2x minus 5y. While on the other hand, in the earlier option, we have a positive 5a multiplying by negative 2x plus 5y. Okay, so either one of this answer is acceptable, since it is not a case of both terms having negative sign. So it is different from our example 2. Let me go back to that. Okay, in example 2, we notice that both of them have a negative sign. So when both has a negative sign, we must take out the negative 1. Okay, in this case, negative 3, because 15 and 6 has a common factor of 3. Okay, so this is where we factorize completely, where we take out all the negative sign, since both has negative in it. While on the other hand, okay, in this case, only one of them has a negative sign. So you can consider just taking out the positive factor instead of the negative factors in this particular option. Okay, let's do one last example to recap our extraction of common factors method. So taking a look at 6x squared plus 15x, we have 6x squared and we also have 15x. So between these two terms, we recognize that there is a common factor of 3 between 6 and 15. And between x squared and x, there is actually a common factor of a single x. So we will take that out, 3x, and then we need to fill in the blanks here inside the brackets. and that is by taking 6x squared dividing by 3x, and that is left with a 2x, and then 15x divided by 3x, that will be a positive 5. And therefore this is the answer for this example 4. I hope that with these 4 examples you are able to recap and recall what is factorizing by extracting common factors. After recalling what is factorizing by extracting common factors, we will now take a look at factorizing by using the cross method. We must keep in mind that the cross method is only limited to quadratic expressions, which I will emphasize more later on. Okay, and maybe for some of us, we have tuition, okay, we have encountered other methods of factorizing quadratic expressions. Okay, it need not necessarily be the cross method. So in fact, if you look at the textbook, it offers a different method. However, I'm not going to use the method found in the textbook. I will be introducing to you another method which we call the cross method. Okay, so the cross method could be a little bit complicated, but after we are familiar with the framework, with the method itself, you will find that it is quite simple to actually go about factorizing. Okay, so this year that will be one of the methods that we're going to learn. Okay, so cross method is one of the methods, and some examples of quadratic expressions are found over here in this list from examples 5 to 8. So we have x squared plus 6x plus 5 all the way to 6y squared minus 11y plus 4. Okay, so we want to express them into two factors. That's the idea of factorization that we have. Before we jump into learning how to factorize quadratic expressions using the cross method, you may wish to recap what exactly is a quadratic expression. So by definition, a quadratic expression is of the form ax squared plus bx plus c. Okay, where a, b, and c are constants and a is not equals to 0. So an example will be x squared plus 6x plus 5, x squared negative y squared plus 8y, and 6y squared minus 11y plus 4. These are quadratic expressions because the power, okay, of x or the power of y, okay, so the power of the variable that we have, it may not always be x and y, it could be a, b, c as well. The highest power that we see is a power of 2. Okay, non-examples of quadratic expression, meaning to say these over here are not quadratic expressions, are things like x plus 7, x, 2y, negative 8. Okay, we observe that the power of the variable x in this case is not 2. There is no square on top of it. Okay, likewise for the y over here. We keep in mind that 2y is not the same as y squared. 2y means 2 times y, which is equivalent to y plus y. But y squared is repeated multiplication of y times y. So y plus y is definitely different from y times y. Alright, so the thing to look out for when it comes to quadratic expression is that we must have a term that is raised to the power of 2. Okay, so let's continue to talk more about it. We need to be able to recognize terms that forms a quadratic expression. So over here I have two expressions, x squared plus 6x plus 5 and 6y squared minus 11y plus 4. Let's take a look at the first expression, x squared plus 6x plus 5. Okay, we have the term x squared 6 plus 6x as well as plus 5. And then the other quadratic expression here, we have 6y squared, we have minus 11y, and then we have a plus 4. So there are three terms in a quadratic expression in these examples that I have. It may not be three terms all the time. There can be two terms, or there can also be one term. So if you were to go back to the earlier slide, let me just switch back. Okay, we know that x squared over here is also considered a quadratic expression. It is so long as one of the term is raised to the power of 2. Likewise over here, it is an expression whereby there is only two terms, okay, and one of it is raised to the power of 2. Okay, so going back to this, after identifying all the terms found in this quadratic expression, we want to be able to relate it to the names of the term that we call it. Okay, so x squared and 6y squared is what we call the term, the quadratic term, alright, or very loosely described as the term with the power of 2. Okay, so the correct term to use to describe it is a quadratic term, but since we're starting to learn it, I will call it the term with power of 2. Okay, so that is your x squared as well as your 6y squared. Then we also have the term with power of 1, and that is actually our 6x and our negative 11y, because there isn't a power raised to the variable, it is actually an invisible 1. Okay, so it is a term with power of 1. Alright, and then finally our plus 5 and plus 4 over here, okay, they don't have any variables with it, they don't have a x, they don't have a y, and that is what we call the constant term. Okay, so that will be our plus 5 and our plus 4. Alright, so I hope that this helps you to recognize the terms found inside the quadratic expression, and this is very important, okay, before we jump into learning how to use the cross method. Okay, so now that we have learned this, right, let's try it on yourself. Okay, if I were to give you these quadratic expressions, 2x minus x squared plus 3, as well as 3 minus 4y plus 5y squared, which do you think is the term with the power of 2? Which one is actually the term with power of 1? And which is the term that is the constant term? You may want to pause the video over here to think about it for yourself first, okay, before proceeding to watch the animation as well as my explanation. Okay, so for the first expression, 2x minus x squared plus 3, we see that we have the 2x term at the beginning is a positive 2x. The power of x is actually 1, so that is actually our term with power of 1. Then the negative x squared that comes after is the term with power of 2. And finally, the plus 3 is actually the constant term. Right? So if you did not get the first expression correct, you may want to rethink the second expression. Okay, how would you sort out the terms found in this second expression? Right, so I hope that you're able to get this answer. So in this case, the second option, okay, so second expression, we have the term 3, positive 3, that is actually our constant term. Then we have negative 4y, that is our term with power of 1. And finally, we have the positive 5y squared, that is the term with power of 2. Okay, my objective of running through this with you is to help us understand that in a quadratic expression, our terms, okay, is not always the first one, the second one, and the third one. Okay, like what we saw in the earlier example. Let me just go back here. Okay, it is not always the first one must be the term with power of 2. The second one must be the term of power of 1. And then the last one must be constant term. It's not always like that. We can always rearrange our terms. Okay, that's what we already knew, okay, regarding expressions. So we see in this example here that the first term, 2x, is actually the term with power of 1. So it's not all the time that it must be the term with power of 2. Okay, although by convention we will usually write it in decreasing powers. Okay, starting with power of 2, followed by power of 1, then ending off with the constant term. But we need not always write it that way. Okay, so we must pay attention to the question that we're given. Alright, so with that, I hope you have a clearer understanding of quadratic expression, okay, before we jump into the cross method next. Okay, now that we have familiarized ourselves with what quadratic expressions are, we will now look back at this quadratic expressions over here to learn what the cross method is, as well as how do we apply the cross method to factorizing quadratic expressions. Okay, so the cross method is unique to the quadratic expression. You cannot use it for any other type of expressions. Okay, so let's take a look at how do we use it. So what is the cross method? In the cross method, we will be using the following frame for the cross method. So usually we will start off with drawing this horizontal line first. Okay, sorry, let me get my animation going. Yes, so we draw this horizontal line followed by a vertical line. So we will proportion our space in this manner. So it's like a table that we're drawing. Okay, larger space over here, followed by one small row here and one small space here, and then after that one space over here. Okay, this frame is going to be used with a specific in a specific manner. Okay, what I want us to know at this juncture is that there are going to be two columns, and in this area that I've highlighted in pink, the things that are going the things to be found there will have to undergo multiplication. Okay, so there are two columns. The things here will undergo multiplication. Then in the very last column here in this area, okay, the terms that we find over here will undergo addition. Okay, so this is a rule that we must follow when doing our cross method. Alright, so I'm going to be keeping this image over here in all the questions that we're going to run through. Okay, so that you keep in mind what is the area that is going to undergo multiplication and which is the area that will undergo addition. Okay, so let's take a look at example 5. Okay, we want to factorize x squared plus 6x plus 5. So this is a very typical question. Okay, they will phrase it for you in this manner. Alright, or maybe they will say factorize x squared plus 6x plus 5 completely. So what we will do is we first draw out the table, the frame that we had, okay, by drawing our horizontal line followed by the vertical line. Okay, and then what we need to do is that we must fill up the space at the bottom area of our frame. Okay, the bottom row. So how do we fill it in? We first take the x squared, okay, by writing it over here. So the term with power of 2 must be found here, and then the plus 5, the constant term, must be found along this side. And then the last one, which is our plus 6x, will be found here. Okay, so we first arrange our terms in such a manner. Okay, now if you recall just now, I said that in this area it must be multiplication. So what are we trying to do here? Okay, I need to fill up this space here by thinking about what are the things that will multiply together to get us x squared. Okay, so we know very easily that x times x gives us x squared. Okay, so this column over here is satisfied. Okay, so that is what I mean by the things here undergoing multiplication. Then for our 5 over here, we will again have to look at what are the things that will multiply with each other to give us a 5. Okay, so for this 5, a very easy one is just 5 times 1 or 1 times 5. Right? So I'll write in 5 and 1. It doesn't matter the order. Okay, you can put 1 first followed by 5, or 5 first followed by 1. Okay, we're now starting out to learn our factorization method, so it doesn't affect our answer. So with the 5 and 1 written down, okay, that multiplies each other to give us this 5 over here. Okay, we will now apply the cross in cross method. So by crossing, I'm looking at x with the 5. I cross over. Okay, and remember we're multiplying in this area, so x times 5 will give us 5x. Then last one, x times 1, okay, will give us 1x, which we will just write as x. Okay, so that is how we get the values or the terms in this area here. Okay, but you may be wondering, where is the addition then? Okay, so this column over here must be fulfilled by doing our addition, and we have to do a check that plus 5x plus x, so when these two things add up together, a positive 5 with a positive 1, they do give us a positive 6. Okay, so with the positive signs that we have over here, I will bring it over. Okay, so because of this positive 5, the plus sign must be placed here, and then because of this positive sign over here, the plus sign must then be placed here. Why do I need the plus sign? Because it reinforces that our positive 5 times positive 1, meaning to say multiplication, okay, will give us this positive 5 as well. So we see over here that in this column, multiplying, okay, will give us the end result of the terms of the quadratic expression that we have. Okay, 5 times 1 gives us 5. And then finally, in our very last column, it is about addition, where we look at positive 5 plus 1, that gives us positive 6. Okay, but this is just the process that we have to go through. It is not the answer. The answer will be x squared plus 6x plus 5 equals to x plus 5 multiplying by x plus 1. So how did I get this? I got it by looking at this row over here. X plus 5 and then x plus 1. Okay, so there must be brackets around the x plus 5 as well as brackets around the x plus 1. Okay, so with this explanation, I hope that you are able to understand how the cross method actually works in helping us factorize this quadratic expression. Let us take a look at another example, okay, where we want to factorize x squared plus 2x minus 15. Okay, so the framework is actually here. Alright, so we will continue to apply this frame, okay, the cross method. So we first draw out the frame, alright, and then we fill in the bottom row of the frame, okay, whereby we have x squared followed by negative 15 and then plus 2x. Okay, so in this case, we look at fulfilling the first column, and we're looking at multiplying two things that will give us x squared. So the simple one will be x times x. Okay, then we look at the second column. Alright, now because in this case we have a negative 15, okay, what I usually do is I ignore the negative sign first because that can sometimes get complicated. I just focus on the positive number 15. Okay, so an easy factor to consider for 15 would be 5 and 3. So you could put 5 and 3, okay, where 5 is on top, or you can put 3 and 5, where 3 is on top. It really doesn't matter. Your answer comes out to be the same. Okay, then we apply the cross, whereby x multiplying with 5 will give us a 5x, and then x multiplying with 3 will give us a 3x. Okay, so now we need to check. Okay, we check in this last column over here whether when we do addition, am I able to get 2? Now, looking at this that I've written at this juncture, I have actually a positive 5x as well as a positive 3x. But we very well know that positive 5 and positive 3 do not add up to be positive 2. In fact, they add up to become positive 8. But we should not be changing anything at the bottom row, okay, of our frame. Okay, what we can do instead is to consider some negative signs. Okay, so by addition, I'm not always talking about addition of positive numbers. It can be addition involving negative numbers as well. So remember, there is this negative sign that I have not yet considered. Okay, so between 5x and 3x, alright, how will I be able to get a combination such that I can get a positive 2? So I hope that you are aware that a positive 5, okay, and a minus 3 will give us a positive 2. Right? So if I were to place my signs in this manner, that will mean that, okay, over here I must have a positive 5. And then after that, over here at the bottom, I must have a negative 3. Alright, and then now we check. Does a positive 5 multiplying with a negative 3 give us a negative 15? I hope you are aware that it does give us a negative 15. So with this, then now we look at the answer to be x plus 5 followed by multiplying with x minus 3. Okay, so that is how we factorize x squared plus 2x minus 15 to be equals to x plus 5 and x minus 3 with brackets around them. Alright, so this is how we factorize using the cross method. Okay, let's look at another example to reinforce what we have just learned. So with y squared minus 8y plus 12, I first draw my frame. I put in our terms, y squared, followed by plus 12, the constant term, then minus 8y. Okay, so looking at the first column, we have y times y to give us y squared. Then for 12, okay, we know that for 12, we can consider perhaps 4 and 3. Okay, and then we do our cross. So y times 4 will give us 4y. And then y times 3 will give us 3y. But now we look at this column over here. Okay, considering the negative signs that we may possibly have to put in, is it ever possible for us to have 4y and 3y to ever give us a negative 8y? Okay, is there a way for us to put in negative signs and plus or positive signs to ever get negative 8y? Okay, I hope you can tell me that the answer is no. It is not possible for any combination of 4y and 3y to achieve a negative 8y. So this process over here, the numbers that we have chosen, doesn't work. Okay, so what we need to do instead is to consider new factors then. So we know that 12 is not just 4 times 3. 12 can be 1 times 12. It can also be 2 times 6. Alright, so we try another combination. So let us draw a new table, okay, a new frame. We put in y squared plus 12 and minus 8y. We know for sure that y times y is y squared, so there's no argument over here. This one is consistent. The only thing that we would now change is the 12. Okay, so we know that 12 can be made up of 6 multiplying by 2. Alright, so let's try this out. Y times 6 will give us a 6y. Y times 2 will give us a 2y. So now we ask ourselves the next question. How can I ever get a negative 8y? Okay, if I were to put in any negative signs or positive sign. Is it ever possible for 6y and 2y to add up to give us negative 8y? There is a possibility, and that is by having negative 6y adding negative 2y. So negative 6 minus 2 will give us negative 8. So because we have considered that this is done already, our negative signs need to be placed over here as well as with the 2 here. And therefore, my answer for factorizing this expression will be y minus 6. We read horizontally, and then y minus 2. Okay, so this is a correct factorization process. And then we write our answer to be y minus 6 times y minus 2. And that will be how we can factorize this question. Okay. We next take a look at example 8. We have a new case where we have 6y squared minus 11y plus 4. Okay, so how this example differs from the earlier one is that earlier on, our x squared and y squared does not have a coefficient, it does not have a number in front of it. Okay, so it's not as simple as y times y giving us y squared anymore. Okay, we need to consider many other possibilities. So we draw our frame, we put in our numbers based on the terms that we are given, then we start considering what are the factors. So what times what will give us 6? We know that 3y and 2y could give us 6y squared. Okay, so we will start that out. I'll start out with that first. Then for 4, okay, I may want to think about 2 times 2. Okay, so with this idea, let's do the cross. 2y times 2, I will get 4y. 3y times 2, I will get 6y. Okay, then we ask ourselves the question, is it possible for 4y and 6y to ever give us a negative 11y when we add them together? So even if I put in minus signs, okay, is that ever possible? Alright, I want us to know that it is never possible for 4y and 6y to ever give us a negative 11y. So this option over here is not correct. It doesn't give us the answer that we need. Okay, so we need to change our plan. Alright, so I draw another new frame. Okay, I put in the things in the bottom row, and then perhaps I want to consider 3y and 2y to give us 6y squared. I'll keep this first. Okay, we change one thing at a time. I'm not going to change this. I will instead change what contributes to a positive 4. Instead of 2 times 2 earlier on, maybe we can consider 4 times 1. Okay, so I place my 4 on top and my 1 at the bottom. Okay, I leave it to you to think about it. What if I were to switch it the other way around? If I place 1 on top and 4 at the bottom, will I still be able to get the same answer? Okay, so with this, I will have 2y multiplying by 4, and that gives us 8y, and 3y multiplying with 1, and that gives us 3y. Then we ask ourselves, between 8y and 3y, am I able to get a negative 11y if I were to add this up, okay, and include some negative signs? It is possible because we know that negative 8 minus away 3 will give us negative 11. Okay, so since we are going to put negative signs over here, it must have come from here. I need negative signs, I need operations over here. So I will have negative 4 and then negative 1. We check that negative 4 multiplying with negative 1 does give us a positive 4. So our bottom row never ever changes. We only change the things at the top. Okay, so this is a correct solution, and therefore my answer that I must write out will be that it will be 3y minus 4 followed by 2y minus 1. Okay, so I hope that with these 4 examples, you have an idea of how the cross method actually works, okay, to help us to solve or rather factorize a quadratic expression. Alright, in my next slide, I'm going to be sharing with you a short summary of the cross method that we have seen throughout these 4 examples. So let us now summarize the cross method that we have just learned through the earlier examples. we must keep in mind that the cross method is only applicable to quadratic expressions. So an example of a quadratic expression that we have here is 3x squared plus 10x minus 8. So in the cross method itself, we must always start off with drawing out the frame. So the frame looks something like this. And in this frame itself, there are various components that we must fill in. The very first step that we must do is to arrange the terms from this quadratic expression into the frame, which is in the bottom row. So how we go about arranging? There are three parts over here. We will first identify the term from this quadratic expression that has a power of 2, and that is our 3x squared over here. And then we put it, then after that we have another term that is 10x, and then the other term that is negative 8. So what we do is that the 3x squared, the power of 2 term, will be placed over here. And then after that, the constant term, which is negative 8, will be placed here. And finally, the 10x term, the term with a power of 1, will be placed over here. It must be in this order, whereby down here must be the term with a power of 2. In the center, it must be the constant term. And then after that, over here, it must be the term with a power of 1. Okay, so we must be very careful about how we see this quadratic expression and then identifying the terms and then placing it over here. So after we're done with that, we will proceed with the second step. Okay, in the step 2, we have to determine the factors that could achieve the terms found in the bottom row. So over here in this column, okay, we need to determine what are the two things that multiply with each other that will give us 3x squared. Okay, and then after that, over here in this column, we need to determine what are the factors, what are the two things that will multiply to give me negative 8. But usually we ignore the negative sign first, we just focus on the number 8. So we are looking at filling this up to achieve this, filling this 2 up to achieve this term over here. And in this area, we are looking at doing multiplication only. So to achieve a 3x squared, one possibility is 3x multiplied with x. So we know that 3x times x will give us 3x squared. Then to achieve a 8, like I mentioned earlier, we ignore the minus sign first. So to achieve an 8, we know that 4 times 2 gives us 8. So we could have 2 first, followed by 4. We know that the order actually matters because later on we will have to do a check. But in this case, I'm giving a correct example. Okay, so I'm just going to intentionally put this 2 here and this 4 over here. Okay, so having 2 times 4 to give us a 8 already. Okay, and then after 3x times x to give us a 3x squared, we can then proceed with the third step, which is to do the cross multiplication. So in step 3, we cross multiply the factors in this manner to achieve the terms in the last column. So x times 2 will give us a 2x, followed by 3x times 4, that will give us a 12x. So we cross multiply the terms to achieve the terms, the things found over here in this very last column. Then we check whether 2x and the 12x, how does it give us a 10x? We must remember that the terms found in this very column, this very last column, is only via addition. Okay, so how do we have 2x adding up with 12x to give us 10x? This is where the step 4 comes in, where we need to determine the signs. So to determine the signs, we need to decide whether to have a minus sign or plus sign in front of our 2x and 12x. And that is by deciding how can we achieve our positive 10x. So to achieve that, we know that if I were to subtract 2x away from 12x, a positive 12x, I will be able to get a positive 10x. So this is where my addition actually works nicely to give us a plus 10x. So with that, okay, that will allow us to have the minus sign over here, and then after that the plus sign over here. So then we check in our final step that each of the column is multiplied or added correctly. we know that this column over here is settled because positive 3x times positive x will give us 3x squared. We usually do not touch anything in this column here. Then negative 2 multiplying with positive 4, that will give us a negative 8. So the multiplication is fulfilled over here. And then in the last column, we see that subtracting 2x from a positive 12x, that will give us positive 10x. Okay, so the addition is actually fulfilled over here. Okay, so therefore, I have actually completed my quadratic expression factorization, alright, after doing my checks. And therefore, I can conclude that my factorization of 3x squared plus 10x minus 8 is going to be 3x minus 2 times x plus 4. Okay, I hope that this summary over here with the animations that I've made allows you to actually familiarize yourself with the cross method. I want us to think about how else could we check whether our factorization is correct or not. Think about what factorization actually meant when I introduced this topic. So earlier on, we said that factorization is a reverse process of expansion. So with that in mind, how could I check that my answer over here is actually correct? I'll leave it to you to think about this, and I'll come back, we will meet again, okay, in our next lesson to address this again. See you again, bye bye. So we'll see each other in our next lesson. In our next lesson, I will be giving you a quiz to assess your readiness in factorizing using the cross method. See you, bye bye.